Okay, so we finished our lab yesterday. We went down in the courtyard and measured out all of our distances from our starting position to our ending position. And hopefully you did 5 or more separate measurements of distance and direction, which are our vectors. So what are we going to do tomorrow in class is, rather than have you go home and work on this lab, you're going to be working on the lab tomorrow. Make sure that you bring graph paper, because that's going to be essential for you to do the lab. And remember, even though we worked in lab groups, each individual student has to hand in their own map or their own vector treasure hunt map. So what we're going to do is we're going to use graph paper to orient your map. So make sure that you understand where the cafeteria is, where my room is on your paper. So normally we call that a north, south, east, and west, and we want to orient our map. Then we're going to mark our starting position coordinate with a star. Now hopefully you'll be smart enough to know, put that on a line. Don't put that like in the middle of a box, because then you're going to have a little bit more difficult measuring distance from not a perfect coordinate. Okay, now where your starting position is should be close to the bottom of your graph paper. And then what you're going to do is you have to figure out a scale. So obviously one box isn't going to be 1 mile. You're going to have to figure out, how many clicks did you go, or how many meters did you go, and what they're going to represent on the map. And that's really up to you, depending on how your map and how your vectors are. And that's probably going to take the most amount of time. Once you determine the scale, you're going to start from that starting point, which is the star on the map, and you're going to draw your first vector using both magnitude and the direction. So for instance, you went maybe 100 meters north. So, and say you said that each box is going to be 1 meter. So you're going to go 100 boxes, and you're going to go straight north from that, and that will be your first vector. And you're going to put an arrowhead on that vector at the end of it. Okay, so now this is where it's a little bit tricky. Vectors can be added in any order. So you can have your first vector, your second vector, your third, and if you add them together, it would be the same as if you had the third, second, and first. The order of the vector addition does not matter. So each member of the group is going to shuffle those vectors into different order. So no 2 people in the group are going to have the same exact map. Then what you're going to do for the next vector after the first one, you're going to use the tip-to-tail method that I explained in the last video, and you're going to keep going tip-to-tail until you've used all your vectors. Remember, you're going to have to take into consideration the distance, which is your magnitude, and the direction, which is going to be the angle that you've moved on that vector. Once you've used all your vectors, that should be your ending position, which is going to be around where the cafeteria is. Okay, now the final thing is we're going to measure our resultant vector from the graph. Remember, the resultant vector is going to be that tip of that end vector, the last vector, to the tail of the first vector. And the way that you do that is you're actually going to take a ruler and measure how long that is. And using your scale, that will be able to give you the distance of that vector. And then remember, a vector has a magnitude and a direction. To find the direction of that, you're going to find the angle and measure that angle using a protractor. Okay, so what do you want to turn in at the end of the class period? First, you're going to have your map. Once again, make sure that it's on graph paper. Make sure that all the vectors are labeled. Label them 1, 2, 3, 4, and make sure that they coordinate with, so vector 1 on your map coordinates with vector 1 down here, which is going to be on a separate sheet of paper, which will be your distance and your magnitude. How you label them doesn't matter. If your group wants to label them 1, 2, 3, 4, and yours are in order 3, 2, 1, just make sure that they coordinate. 1 coordinates with 1 down here. Make sure that you set your scale. Tell me that 1 block equals 1 meter, or so on. And make sure that you have a nice title for the graph. Okay, then you're also going to hand in another sheet of paper that's going to label all your vectors. You're going to have 5 or more. You're going to have, remember, a vector has a magnitude and a direction. So you're going to say, 10 meters, 45 degrees. So make sure each vector has the magnitude which is the distance, and the direction, which is the angle. And then the final thing is you're going to calculate the resultant. What I'm going to have you do is go back to the graph paper math, and you're going to draw your resultant in a different color than the original vectors so that it kind of highlights which is the resultant. And then you're going to make a measurement and give me that number, the magnitude and the direction on that map. Okay, well that's going to be what we're going to be working on tomorrow. So once again, make sure that you have graph paper, because I will not accept at all a handwritten map turned in without graph paper, because the graph paper is essential because we are doing geometry measurements and it's very important. Okay, well, for tonight, there is no homework. You don't have to do a video Edline assignment, but make sure that you do bring the graph paper in tomorrow for class. We'll see you tomorrow. Bye.